everyone, welcome back to our channel Smart Everyday Overlearning. Dear students, we have been learning the topics from the chapter Organic Chemistry, some basic principles and techniques. In that, the subtopic is what we started yesterday about qualitative analysis. In that qualitative analysis, yesterday in our class, the detection of carbon and nitrogen and hydrogen. These three elements completed. Now students, in this session we are going to learn about detection of halogens, and in that again Lassaigne extraction preparation, and by using that Lassaigne extraction what we have to do to detect the halogens, and Beilstein's test also let's see in this session. In this qualitative analysis, only detection of halogens nothing but, you know very well, chlorine, fluorine, bromine and iodine. If these are presented in the taken organic compound, what we have to do and how we can detect them, let's see now. Beilstein test. Okay students, completely in this test, it's very simple and sensitive test to detect the halogens just by observing the flame color. Let's see the preparation of Beilstein arrangement, the complete arrangement, and how we can do this Beilstein test. Let's see briefly, and what are the limitations involved in this test also let's see now. The presence of halogens in an organic compound is detected by Beilstein test. Okay students, Beilstein test, you can see here what are the apparatus you need to take to do this Beilstein test. Instead of this Bunsen burner also you have to take. It's a very simple and sensitive test for the detection of halogens in an organic compound. In this test, a clean and stout copper wire is heated in the non-luminous flame of the Bunsen burner until it ceases to impart any green or bluish green color to the flame. Now we have the equation here, the oxidation of the copper, then copper oxide has come here, then you can see the flame, the color of the flame also bluish green color on the flame. The heated and is then dipped in the organic compound, and students, we have to do this again, introduced into the Bunsen burner. Now you have to see the appearance of a green or bluish green color flame due to the formation of volatile cupric halides. This indicates the presence of halogens in the organic compound. Okay students, now in this you have to see some limitations also. For suppose the organic compounds like urea, thiourea, etc., which do not contain halogens, also give this test due to the formation of volatile cupric cyanide, this type of bluish green color flame. And it does not tell also as to which halogen, just like chlorine, bromine or iodine, is actually present in the organic compound. Now you can see the equation of this, and if you add some hydrochloric acid to that CuO, and students, some halogens also you need to detect from just by doing this experiment Beilstein test, just by observing the color of the flame. And to this this is about Beilstein test and how we can detect the group of halogen by observing the color of the flame, right? And students, now let's see about Lassaigne extraction, and just by using this Lassaigne extract, how we can detect the halogens and the presence of halogens, which must be either that is chlorine or bromine or iodine. Okay, from the organic compound, let's see now what is the preparation of Lassaigne extract. Okay students, just by using this Lassaigne extraction, we have to do the experiments to detect some halogens. Now let's see the preparation of Lassaigne extract. This is the organic compound what we have to take for the detection of halogens, right? And students, the most reliable test for detecting that halogens in the presence of organic compound, in this test the elements present in the organic compound are converted from covalent form into the ionic form. And what are the apparatus you need to take for doing this extraction? This is the fusion tube, and these are the equations of sodium metal with halogens and cyanide also. Okay, these are the chemical equations you are seeing on the screen. And now it's a boiling process of a small piece of sodium metal. Here what you have to take, what are the apparatus, and this is the organic compound containing halogens present in that. And what are the materials required to do this activity? Metallic sodium and the distilled water and organic compound and forceps, test tube stand and forceps and tongs, funnel, filter paper, wire gauge and tripod stand, Bunsen burner. Right, now let's see the procedure. First of all, you have to take with the help of forceps a small pinch of sodium metal, that is freshly cut sodium metal, the size of a just like a pea. It is heated gently in a fusion tube with the help of forceps that you have to take in that fusion tube, and this is the tongs. With the help of tongs you need to place that fusion tube on that Bunsen burner. Then students, what will happen? It is gently heated. Then take a small pinch of that nearly 50 to 60 milligrams of organic compound is added to that fusion tube and heated strongly till it becomes red hot. Just 2 to 3 minutes. Then the hot tube then plunged into a china dish containing 10 to 15 ml of distilled water. Then the contents of this china dish are boiled for few minutes. Then after that cooled and then filtered. Okay, you are seeing on the screen. Then this is the cooling process. Then now we have to filter the complete solution into a beaker. Okay, now you have to get the Lassaigne extract. Now what are the precautions? Always use forceps while handling the sodium metal because it is highly reactive. And before using sodium, press within the folds of the filter paper to dry it. And use dry fusion tube for sodium fusion. And repeat this process of sodium fusion with 2 or 3 ignition tubes. Ensure the fusion has taken place. And right, it's about the preparation of Lassaigne extract. Now let's see, just by using that Lassaigne extract, what we have to do. This is the main basic equation to this sodium metal. If you add the halogens just like chlorine, bromine, iodine and fluorine also, then NaX, sodium halide will form, sodium halide. Now test for halogens. Take a part of Lassaigne extract is boiled with dilute HNO3. Extract plus dilute HNO3, then and you have to cool it. A few drops of silver nitrate solution is then added. Silver nitrate, nothing but AgNO3. Okay, then students, if you observe a white precipitate soluble in ammonia, and let's see, when the reaction of NaCl with AgNO3 silver nitrate, then AgCl silver chloride has been formed in the form of white precipitate, white PPT, and sodium nitrate also will be formed. Here is the white precipitate soluble in ammonia. It is soluble in ammonia and insoluble in dilute HNO3. Dilute nitric acid. If it is insoluble in dilute HNO3 nitric acid, then it indicates the presence of chlorine. Okay, presence of chlorine in that particular organic compound what we have taken. Next one, for suppose yellow color precipitate NaBr, to this if you add, this is the organic compound, okay, to this if you add again silver nitrate, then students AgBr, silver bromide, this is just like pale yellow color precipitate, and along with that NaNO3 sodium nitrate also will be formed. Okay, This indicates a pale yellow colored precipitate. This is partially soluble in ammonia, partially soluble in NH3. This indicates the presence of bromine, in that particular organic compound what we have taken. For iodine, the next one for iodine, this is the organic compound or else a sample what we have to take. Okay, for the detection of iodine, if you add silver nitrate to this sample, and students, what you should get? Silver iodide. This is also yellow color PPT, nothing but precipitate, along with NaNO3, sodium nitrate. Okay, sodium nitrate. And this yellow color precipitate insoluble. This is also insoluble in ammonia. This indicates that presence of iodine in that particular organic compound what you have taken. Right. Now let's see the function of nitric acid. HNO3, the function of nitric acid. If the organic compound also contains nitrogen or sulfur. Now the Lassaigne extract on the boiling process with dilute HNO3 decomposes sodium cyanide just like NaCN, sodium cyanide, or sodium sulphide also formed during fusion. This is the equation: sodium cyanide plus nitric acid and sodium nitrate, hydrogen cyanide is formed in the just in the form of gaseous state. And if you take Na2S, sodium cyanide, to this if you add HNO3, again nitric acid. Okay, here also same, sodium nitrate and H2S, hydrogen sulfide gas will be formed here. Let's balance this equation. Here 2 hydrogens, then if you place here 2, and here 2 sodiums, then if you place here 2, then the equation should be balanced here. For suppose, students, you can see if cyanide and sulfide ions, this cyanide, CN ions and sulfide ions are not decomposed, then they will react with silver nitrate and hence will interfere with the test. See this equation: sodium cyanide plus silver nitrate. Here silver cyanide with sodium nitrate. This is white color precipitate. And if you add same silver nitrate AgNO3 to this sodium sulphide, and here Ag2S, silver sulphide, this is black color precipitate, including with that sodium nitrate NaNO3. And if you balance this equation here, Ag2S, silver sulphide, so here if you place 2, then here Na2, then if you place here 2, then students equation should be balanced. Now let's see, this is about test for halogens. Up to now about chlorine, detection of chlorine completed, and detection of bromine completed, and detection of iodine also completed. Now carbon sulfide test for bromine and iodine. Let's see. Carbon disulphide test for bromine and iodine. Up to now, students, the first one is Beilstein test and Lassaigne's test also completed to detect some halogens. Now this is to detect bromine and iodine. Okay, here a small portion of again Lassaigne extraction you need to take for this. Lassaigne extract, this is boiled with dilute sulfuric acid, nothing but H2SO4, to decompose sodium cyanide and Na2S, that is sodium sulphide. The solution is then cooled when a freshly prepared chlorine, water and carbon disulphide or carbon tetrachloride carbon tetrachloride. These two are added. The solution is vigorously shaken and yellow stand when what you have to observe, an orange color. If you place it for a few minutes, then students, you have to observe first of all an orange color in CS2 or CCl4, carbon tetrachloride layer, indicates the presence of bromine. This is the presence of bromine. And for suppose if you observe a violet color in the CS2 and CCl4 layer, this indicates the presence of iodine. Okay, these two are the color indications to detect bromine and iodine. When you add to this Lassaigne extract dilute H2SO4 to decompose these two. Right, now the theory of the test, let's see. This is due to the reason that chlorine displaces bromine and iodine from their corresponding halides. The halogen thus liberated dissolves in CS2 and CCl4 to produce the specific color. You can see the example here, NaBr, sodium bromide and chlorine, and here sodium chloride and bromine. This is dissolves in carbon sulfide and carbon tetrachloride to give orange color, to produce orange color. Next, for suppose in presence of iodine, 2NaI plus Cl2. Here the same equation, 2NaCl plus I2 should be formed here. I2 should be formed, and here it dissolves in CS2 or CCl4 to give here violet color. Okay, this is the theory of the test of carbon disulphide. Now, okay students, this is about our today's session, how to detect some halogens which are present in that particular organic compound what we have taken. I would like to know complete your opinion and what is your view of this class. Okay, you need to convey in the comment section, right? Okay, if you like this class, please subscribe and click the bell icon for my further updates. Thanks for watching.